We've kind of finished a chapter, chapter 2, limits. It's done. You guys sound good for a Friday. Sometimes Friday morning you kind of, you guys sound good. And we're moving into chapter 3 briefly. I don't like to give an exam right at the end of chapter 2. I have a couple more sections we're going to cover because you're going to find that what we do today is we really go back to the very first day of class when we said, what is calculus? And you might remember we showed you some pictures. And the one I spent the most time on is the main focus of today. We talked about secant lines and we talked about a tangent line. We talked about the tangent line being the limit, in a way, of some secant lines. And we said that's why we have to study limits. So we did. We studied limits for, well, a couple weeks, and now we're back. We're back to the main problem. And so that's where we're going, okay? We're going to see if we can understand the relationship and one of the two big problems in our calculus course. So I'm going to start off with a formula that should look familiar to you. See, if we want to find the slope of a secant line, right? So I wrote M with a little SEC for secant. Then that's my formula, right? I appreciate you guys sitting in the same groups. I have some group work for us today, but I kind of feel like I got to give you a little bit of background since we're starting a new chapter. So, I don't know, I guess I'm going to draw a curve. No, like we had the first day of class. We had, if I remember right, I think I drew a parabola, and I had a point P. And then what I did was I took some different points, like Q1, Q2, Q3. You guys remember this? Here's Q1. And then later I did Q2. And in each case, what I was doing was finding the slope of a secant line. But my goal was to find the slope of this tangent line. That was the goal. Remember that? Let's zoom in. That's pretty small. So I'm going after the slope of the red line. And I can find the slope of the blue line, and then I can find the slope of this green line, which will be a little steeper. And somehow, if I take the limit of those slopes, that's the idea. And so again, if I write my formulas down, the slope of a secant line, well, we know that the slope is given by what? y2 minus y1 over x2 minus x1, right? A lot of times we'll write change in y over change in x. And if I give point P some coordinates, okay, so let me do that. Then I can actually maybe compute some things. So, for example, if I make the x value equal to something like c, then the y value will be f of c. I'm going to make that the coordinates of point P. Now point Q, you notice I'm varying point Q. So maybe point Q, I'll say that the coordinates are x and f of x, because I'll change it. That's a variable. You guys with me so far? So what that means is the slope of my secant line I can express as, I guess y2 minus y1 would be f of x minus f of c over x minus c. There it is. And now, what I'm interested in, of course, is the slope of the tangent line. And I claim that that's a limit. The limit as what approaches what? Well, it's the limit as x approaches what? C. As the x, if you have the x-axis here, right, somewhere down here, then I guess here's C, and the x's are going to be approaching C, and we want to see what happens to this slope. F of x minus f of c over x minus c. You guys with me? So now I'm going to do a few tricks to this red formula. Because if you go ahead and did the reading for today, this is not the first formula they gave you for what we're going to call the derivative. This is something the book would have called the alternate formula, and they gave it a few pages later. But I like it to start because, to me, this one makes sense geometrically. I can see what's happening. Okay. So the actual formula we're going to use, right? Here we go. The slope of the tangent line I just gave. We're going to talk about the derivative. So let me go ahead and kind of go through it in order I usually do. Here are three formulas that the top one I just gave to you. But I want to explain kind of where the next one comes from. Okay? Now the way you're going to read that first symbol with the apostrophe, we're going to call that prime. Okay? F prime of C. But just so you know what that means for us, geometrically, it means the slope of a certain tangent line. Which tangent line? Which tangent line does this one mean? Well, the one that you have on your picture if you drew what I have. Okay? So let me go back to that. Here's my new formula. We're talking about that red tangent line because that's the tangent line again when x equals c. Right? That's what I'm after. So now a couple changes I made. Right? You notice I didn't write x minus c anymore. What did I write? Well, I wrote delta x. So delta x is the same as x minus c. So on the picture, I guess it depends which step I'm at. But initially, this is delta x, right? And we knew that when we were computing the slope. It's x minus c. That's how you compute the distance. Does that make sense to people? Okay. And then you notice there's one other change I made. What's the other change that I made?
C plus change in x.
Yeah. I wrote c plus change of x instead of what? Last time I wrote x, right?
Yeah.
Now, are those the same? Well, it turns out, yeah, they're the same, and you can see it from the equation we just wrote over here, right? Because if you solve for x, what does x in fact equal? Yeah, because you add c to both sides. You guys with me? So this formula in green really is the same as the formula in red, but it's kind of disguised. If I give you this formula, it's harder to see what's happening. But it's still this picture. You guys understand that? So as delta x gets small, oh, wait a minute. Yeah, I didn't write down limit. Shoot. So I'm going to write limit not as x approaches c anymore. Because as x approaches c, what happens to delta x? It approaches 0. So now I have it correct. F prime of c, the slope of the tangent line at c, is equal to this formula. And by the way, these formulas I'm writing down, they have a name, all three of them that I'm about to write. They're sometimes called the difference quotient, all these fractions, because what's quotient mean? Divide, and what are you dividing? A couple of subtraction problems. So if you ever see the book talk about difference quotient, they're talking about these big ugly fractions. But they're the same. It's just a little substitution was made. And now there's one more substitution that I make, and it's this. Is there anything special so far today about the point C? Did I tell you what number it is? Couldn't it be any number? I mean, it could be any point up there on the graph, and you could play the same exact game. And so now what I do is I get the C out of there, and I throw an X in there. So that's my variable. You see, you can compute this limit for any value of X. And the only other change I'm going to make is delta X gets to be a lot to write. And so a lot of books, including ours, will write H rather than delta X. So then, what does my formula look like? Okay. Well, I have f prime of x equals, and here it is, f of x plus h minus, oh, I'm missing something, guys. I keep doing it. What I forgot to write? Limit. Let's try that again. So, let me give you an actual definition, and then I'll make the substitution. Okay? Here we go. Let f of x be a continuous function. Ooh, there's that word we studied last time. A lot. I will not talk about what I'm going to call the derivative unless I have a continuous function. Got to have continuous first. Okay? Okay? Then the derivative of f of x is given by the formula f prime of x is equal to the limit. Now I told you I had delta x going to 0. Just for notation, we're going to write h go to 0. Okay, that's going to take the place of delta x of, and now what goes up here? It would be f of, and remember I'm replacing the c with x. So it's f of x plus h minus f of x all over h. So there's my formula. Oh, one more thing to write though. Provided that the limit exists. Because we've seen lots of times, no, I guess we've seen lots of problems where the limit doesn't exist. We've also seen lots of problems where the limit does exist. But if you have a continuous function, what's the first thing you always try? Continuous, you just plug in, right? So I guess the question is, what happens to my formula if I plug in a 0 for the h? Well, can I? Why not? So you'd get a 0 in the denominator. But, do you notice anything else? We get f of x minus f of x, so what are we getting in the numerator? 0. So in general, you have this indeterminate form. You have hope that maybe you can compute this limit. And the answer is that with the functions we're going to be dealing with, yeah, we usually can. And so this makes sense. This is a... Did I say anything very special about f of x? Well, I said one thing. What do we have to have about f of x? It has to be continuous, okay? If it's not continuous, not differentiable. Oh, the word I just used, differentiable. Let me write that down, because that's one that usually gives people headaches. Differentiable, which obviously, I guess, would mean able to, well, differentiate, okay? But that doesn't help you much. Differentiable is going to mean able to, and we're going to call it take the derivative. This is still kind of garble because derivative, what does that mean? Well, that's what I defined. The derivative is going to be a new function that comes from a function. And the new function is going to give me slopes of tangent lines all over the place for anything you put in for x. So you need an example for sure. One of my favorite examples I always have right here on this next slide. Here we go. If f of x is x to the fourth power, we want to try to compute f prime of x. And you're going to need some room. So I'm going to get a new sheet. All right, so here I go. F of x is x to the fourth. What do I want to do? I want to determine what's called the derivative. So I'm going to write down the formula again. F prime of x is equal to the limit as h approaches 0 of what's called the difference quotient. F of x plus h minus f of x all over h. That's what I have to compute. The last part of computing this usually is the limit. So I'll just write limit as h goes to 0 down again so I don't forget it. And I tell people what I do next is this. I'm going to write down the h, and what I fill in next is this f of x. What is f of x? Right. So I'm going to write down that we are subtracting x to the fourth power, right? That's what's being subtracted. And now the question is, do you know what goes here? Well, yeah, it's x plus h to the fourth power. Does that make sense to people? Because the function was f of x. When you write this expression, f of x plus h, that means anywhere it used to say x, right, x plus h. You guys got it? So all we have to do now is simplify this big ugly fraction, and we got it. And do you guys know what you get when you take x plus h to the fourth power? No. I was just doing my algebra class yesterday, and we had x plus h to the second power. And I'll tell you, how many of them put x squared plus h squared? I was ticked. Right? When you, for example, if I square a binomial, what's the algebra rule? If you square a binomial, you get what kind of polynomial? A trinomial, right? What do I get? Help me out. X squared plus 2xh, yep, plus, yeah, my algebra teacher used to say square the first, double the product, square the last. And so I showed him that yesterday. It's kind of fun that my algebra class, comes into handy here, right? But what we have is x plus h to the fourth power. And I will just tell you for the time being that that is the following. It is x to the fourth plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth. How many of you knew that? 1, 2, 3, 4. That's it? All right, so I have something to teach you today, I guess, about algebra. So here I go. But everything else stays the same. You guys with me? No, you can't see anything. Thank you. All over h. So that's what it equals. The powers of x go down. The powers of h go up. That's not surprising. I think what is the trick is understanding where these coefficients come from. The 4 and the 6 and the 4. But it's not too difficult. It's kind of like what happened over on the left. I'm about to move back. Where did that 2 come from? What's that? Leo? Why do we get that 2?
Because it's 1xh plus 1xh.
Yeah. It comes from when you first outer, inner, last, right? So you do outer and inner. Matter of fact, if I want to know what x plus h to the 4th is, all you have to do is take this trinomial, multiply it by itself, right? You'd be done. But that's a lot of work, right? You'd have 9 multiplications to do and then combine like terms. I mean, let's just do this one, x plus h cubed. What's that mean? It means take x squared plus 2xh plus h squared times another x plus h. Right, guys? So what do I get? Well, what's the first thing I get? X cubed. And then if I continue to distribute that x, I get 2x squared h plus xh squared. And then what do I have to distribute? I got to distribute the h now, right? So when I distribute him all the way to the front, let's say, I get another x squared h, and I get another 2xh squared, and I get another h cubed. Are you with me? So what the heck does x plus h cubed equal? X plus h cubed equals x cubed plus 3x squared h, right? Plus 3xh squared plus h cubed. Are you with me? The powers of x go down, the powers of h go up. But again, these 3's are what are important. That's the part that you may or may not know about. By the way, you could also do x plus h to the first power. That's x plus h. What's x plus h to the 0 power?
1.
Okay, that's 1. And now, if you just were to look at the coefficients, you know, at the top of this I have a 1. And then I have x plus h, I have 1, 1. And when I have x plus h squared, I have 1, 2, 1. And when I have x plus h cubed, I have 1, 3. You've seen this before, right? What is this called? Pascal's triangle is what it's called in the United States. Bless you. It's actually much older than Pascal. I mean, the Babylonians of 2,000 years ago knew about this. It's in their artwork, okay? But for some reason, Pascal did enough mathematics that he gets his name associated with this. And so when you ask me, well, how do I know what x plus h to the 4th power is, it's something you may have learned about called the Binomial Theorem, which tells you that, hey, if you have a binomial and you're raising it to a power, the coefficients are going to come out of Pascal's triangle. That's kind of a nice way to word it. Oh, and what's the pattern for Pascal's triangle? Where's the 3 come from? 1 plus 2. So if I want to get the next row, 1, 4, 6, 4, and 1. And that's really nice to have. Because now I go ahead and I want to compute x plus h to the 4th power. I do 1, 4, 6, 4, 1. There it is. I just think that's nice to see if you haven't seen it before. All right, that's algebra. Back to calculus. Ready? So here's calculus again. I'm computing the limit as h approaches 0 of this difference quotient. Hey, what the heck am I trying to do again? What's the original problem? It's real easy to lose focus of that on these big problems, especially when I start doing algebra. Find the derivative of the function, which function? X to the fourth. All right, we're back there. We're finding the derivative. So what do we do next? Do you see anything I can simplify? The x to the fourth, that's right. We're adding it here, we're subtracting it there. So let me write it out, what we have now. We now have 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the fourth all over h. All right? What's that? We can take out some h's, right? Now, the mad slasher inside my algebra students wants to just take that h and cancel them, but you can't, right? You need to factor out an h first. So we do that. And by the way, those of you that did the Chapter 1 review, I'm passing that back today. You did about maybe 5 or 6 problems kind of like this. They didn't tell you they were calculus problems, but you're simplifying difference quotients. So you've actually already practiced this. The limit as h approaches 0, I'll factor out an h so that I'll be able to cancel it. We've done that trick before. So what am I left with? Let's see. 4x cubed plus 6x squared h plus 4xh squared plus h cubed. And so now those h's cancel. And so what I need to do is take the limit as h approaches 0 of just the stuff in parentheses. 4x cubed plus 6x squared h. And when you have the stuff in parentheses, it's continuous now. You are allowed to plug in h equals 0. And so, after all that work, I have just computed that f prime of x equals what? Well, 4x cubed, right? Plus 0, plus 0, plus 0. So 4x cubed. And there's our first derivative. Are you with me? What's it mean? It's a lot of work, but what's it mean? X to the fourth, and somehow the new function 4x cubed is its derivative. It goes with it. Well, that's actually, here's an application, okay? And when I make this slide, I always laugh because I see how it could easily be misread. I said, find an equation of the tangent line at, doesn't that kind of look like 5,000 something? I didn't mean that. Do you understand what I meant? What I meant x equals 5 and y equals 625. Actually, does that make sense to you guys? Because 5 to the fourth power, right? So 25 squared is 625. You guys understand? So I want to find an equation. So first of all, let's go back to the picture. Let's draw the picture of f of x equals x to the fourth. Do you guys know what that looks like? Have you ever graphed x to the fourth? What's it look like? Can you show me with your hand? Oh, only a few know this. What does x squared look like? Can you show me with your hand? Ah, yes. Well, x to the fourth looks kind of like that. But it's steeper, right. Let's see how much steeper. So I'm going to start to plot the graph for us. So let's see. F of x equals x to the fourth. Here's my axes. So it goes through 0, comma, 0. It goes through 1, comma, nice job. It goes through -1, comma, hello? 1, okay. It goes through 2, comma, 16. I'm already getting off the map, right? It goes through 5, comma, what? 625? Let me zoom out. So here's my fancy zoom out picture. You have to understand something about x to the fourth. It really shoots up rapidly. And you see this drawing? This is not right. It's not to scale. I mean, it takes off. Are you with me? And somewhere here, I could draw a tangent line at the point 5, comma, and then I got to be careful about this so it looks right, 625. What would you tell me about the slope of that tangent line? Practically, would it be big or small? Remember, what's the slope of a horizontal tangent line? 0. 1. It's big. Now infinity, of course, that's bigger yet. But it's a big slope. Now if I want to find the equation of the line, I need to find the slope, and I also need to find what? The intercept, the y-intercept. So that's our game. Well, what the derivative allows me to do is to find the slope. Right? So anyways, I'll remind you of something that you learned in algebra again. You at some point learned about point-slope form of a line. So let me remind you of that. Because everyone knows y equals mx plus b, slope-intercept form. But you can also get a line like this. Y minus y1 equals, does anyone know? M times, yeah, and this is useful if you know a point, which we do, and if you know the slope, which we're about to get. So I'm going to write y minus, and where it says y1, what are we going to write? 625. That's the y-coordinate of the only point I have. Y minus 625 is equal to, now do we know the slope yet? No, but we can get it. This slope will be given by, well, from the derivative. Let me compute it now. F prime, do you know what I have to put in for x? 5. Because that's the x value. This will give me the slope. So the slope is 4 times 5 cubed. 5 cubed is 125 times 4. Wow. 500. Have you ever had a problem with the slope of 500? Now you have. So the slope is 500. We just computed that using the derivative. Remember, the derivative can give you the slope at any point you want. So it's very powerful. Times x minus what? What do we put in for x1? 5. So that's an equation of the line. Now, again, we're not so familiar with that, so let me put it in slope-intercept form for you. So I'm going to distribute the 500. Let's see. Y minus 625 is equal to 500x minus 2500, right? And then I'll add 625 to both sides. So I'm getting y equals 500x minus, is that, bless you, is that 1875, I think? Okay, so there's the equation of my tangent line. And actually, does that look right? Reasonable, right? I mean, your y-intercept will be way down here somewhere. And the slope is 500 to get there. You guys follow? So that's the derivative. We've had one example so far. And that's it. I'll come back to this maybe later. I want to get you guys working on the group work. So we'll do that. And have you get something out of it. Here we go. F of x equals x to the n power. You guys all right? Should I do this or no? Yeah. Oh, okay. So f prime of x, by definition, is the limit as h approaches 0 of f of x plus h minus f of x all over h. That was my new definition for today of the derivative. And again, it's a function that can help me find the slope of tangent lines. And actually, we did a special case already. We did x to the fourth. And what was the answer?
4x.
4x to the third. And I actually saw other people did special cases as I walked around. One group did x squared, and they got 2x. And we'll talk about quick ways to compute that on Monday. But in general, what you do is you use this formula. You say, well, f prime of x is the limit as h approaches 0 of what? Well, of x plus h to the nth power minus x to the nth all over h. Is that okay? And so if you remember what I did last time that I did x to the fourth, I did a big expansion, and I put the h there. And then I said I always like to write this part next because that's easy. The hard part usually is to write this in some other form so that I can simplify. But I mentioned to you guys Pascal's triangle, right? That can be helpful. Matter of fact, the first term is going to be x to the n. Would you guys agree with that? Because it's a 1 in front.
Yeah.
The next term is going to be n times h times x to the n minus 1. And you could check that that's true. That's where the 4x cubed came from. And the other stuff has like h squared, etc. in it. And what happens is these go away. And then you pull out an h. And the only stuff that doesn't have h in it after you cancel is this. And since it's 9:26, I really got to stop here. Okay? But nice work today. This weekend you'll do more of this kind of stuff for homework.